So I'm excited to have you all here today. I'm going to pass it over to Katie. And if you have any questions about SAP or anything along those lines, I will be here throughout the whole event.
All right, thank you so much, Stephanie. Can we give a round of applause to SAP just for this venue? It is so beautiful, and I feel like super cozy. Yes, thank you so much for letting us this venue for the meetup today. We're super excited to host this, and let's just jump into it. All right, down, I believe, or not? Question mark. Okay, manually. All right, so just starting off, I'm Katie. I will be your host for today's meetup. I lead global events marketing here at Zilliz. Feel free to scan the QR code there if you'd like, just to connect with me on LinkedIn. Before we do start the meetup, it's working now? Perfect. Okay, thank you. Before we do start the meetup, we're just getting to some community guidelines. So please, please, please just be respectful and kind and open to everyone's ideas. We're going to be talking about different advanced topics today. So just have an open mind and get ready to learn. If you do see any inappropriate behavior, please report it to one of our Zilliz or SAP staff outside. But yeah, I don't expect any of that to happen, so don't worry. And then on to some more housekeeping. So we are hiring. If you are interested and looking, just go ahead and scan that QR code there. I also will be sending out the slides after this meetup. So there's gonna be lots of QR codes. Don't worry if you miss it. You'll get it after the meetup. And then also, if you're not already on there, go ahead and join our Milvus Discord. Best place just to find, latest updates, get connected with our community a little bit more. So if you like what you see, what you feel here, go ahead and hop onto our Discord. And then also, you probably heard on the way in, but we are hosting a raffle giveaway tonight after our speakers' talks. We're giving away some Labubu and Milvus swag. We're giving away 2 giveaways. So if you are interested, go ahead and star us on GitHub. There should be some tabletops on the tables where you can just scan the QR code. And then if you want to raise your hand, Fendi and Jenny, they can give you some raffle tickets, or they'll be over there at the registration table. If the GitHub, I heard, it's been kind of like acting weird. So feel free to also follow us on LinkedIn as an alternative. All right, if you are interested in becoming a speaker or sponsoring a future meetup, go ahead and scan that QR code as well. We would love to see what partnership opportunities can arise together. All right, lastly, if you take any photos here at the meetup today, go ahead and tag us and use the hashtag Zilliz unstructured data. We would love to see the photos and possibly repost them onto our socials. All right, sorry. I think this is the last slide. If you want to get started with us, we have our Milvus open source vector database and also our Zilliz Cloud fully managed SaaS offering. And you can go ahead and scan those. Now let's finally get into the speaker talks. Today we'll be going over our Milvus roadmap. We're going to talk with Airtable on how they built semantic search with Milvus. And then lastly, we're going to have a talk from SAP on how they design Agentic AI. With that, I'm going to just move on to our first speaker, our very own Jiang from Zilliz.
All right. So first of all, thanks, Katie, for giving the introduction, and thanks SAP for this beautiful venue and the food. I'm really, really grateful for having so many people here, because I was joking with our colleagues. What if we would just get less than 10 people? Maybe we'll just find a tap room and then drink some Imperial IPA and talk about search and information retrieval. But apparently that plan has failed. Thank you so much for coming, and I hope this tonight will be will both be enjoyable and fun, and also a good learning opportunity. And also, I kind of ran through the list of guests today, and I think we have a perfect blend of search gurus, people working on data infrastructure, data data engineering and also people working on the search relevance, business logic, or AI development side. I think that would be great if you talk to each other after the, these few talks. Hopefully you will enjoy the conversations there. And a bit about myself, I'm working for Zilliz. So first of all, this is not a scam. So Milvus is actually the open source project developed by us a few years ago. So even though that's a different name because we donated it to Linux Foundation. I run the developer relations here, responsible for user success. Before this, I was working for Google on search indexing, mostly being a user of something similar to a vector database. And when we talk about search, here's the kind of common pattern that I'm seeing. So there's, of course, a business problem, right? We want to serve the internet to users, or we want to build an awesome RAG or search application. And then you go ahead, prototype with a bunch of tools, whether it's lexical search, which was like a decade-old technology, or it's embedding-based AI, so-called AI search. And then after you got the basic workflow done, say you plug the embedding model to a vector database, and maybe you also plug it to a large language model to provide some summarization. And then you want to improve the quality because eventually this is not only a Twitter demo. It's probably you want to launch it into production and then serve millions or even billions of users. And there are two things there you probably want to do. One is quality optimization, which is experiment with all kinds of different business logic, such as what if I do hybrid search, adding another path to the retrieval? Or what if I say add filtering or label filtering to kind of guardrail my search experience? And after doing all this experimentation, you will run some quality evaluation. And probably even after launching to the production, you will run A/B testing or continuous quality monitoring. But once you feel comfortable with the search quality and relevance, you want to launch it to production. And then there comes the infrastructure challenge. Say, what if there's a gigantic amount of data to search for or search from? And that's much more than was available in a Twitter demo. Say hundreds of millions of documents or even billions. That will create a unique problem. And today I want to focus on the last part, which is how to productionize the prototype or an optimized search workflow by delivering the good search quality consistently. And the way I would like to kind of have an overview of the problem space of search serving, right? What are the types of search serving? They're actually pretty different. I kind of model it as one dimension is search QPIs, like how frequently users are clicking on the search box or asking large language model, which triggers their search. On the other dimension is the corpus size. How large is the corpus that you want to search from? Is that internet scale? Internet scale is generally considered as 100 B, I would say, or it depends on how people define internet. Not all of the internet is indexed, actually, or is I think traditionally enterprise search was seen as maybe there isn't that much data because how many documents you can get from enterprise, maybe not as much as internet or say TikTok or something, UGC, like user generated data. So interestingly, there's a huge space of different use cases and they vary differently. A few examples, web search is both high QPIs and large scale in terms of the corpus size. And there's recommendation, usually the corpus size isn't that big because if that's really, really long tail data, it's not worth recommending to users or serving. And there's also, I would say, data mining, which is the other extreme. It's super large scale data corpus, but the access frequency is really, really low because you don't really have millions of users running the data analytics platform. It's just a few data scientists in the company. But they are dealing with a large scale data, for example, for autonomous driving companies. they are probably handling hundreds of billions of images collected from the road because it's really easy to generate that data. You have so many cameras, so many cars, and they run 24/7. And there's some AI, so-called AI applications. Say, I kind of divided it into consumer agent and internal agent. Internal agent is more like a modernized enterprise search. Search through your documents from the enterprise. That's usually not as large scale as consumer agent, which is serving some kind of a web search-like experience, but not on internet data, instead on some interesting vertical data. One example is File1, which is also a customer of fully managed Milvus. They are actually serving the legal documents, including historical cases, meeting notes, and that's easily, because they are managing these corpus for thousands of legal firms, and that's easily billion scale data. The other use case is open evidence. They are serving the medical records, medical research information, such as research papers and maybe research notes to their customers. And that's also monolithically a big corpus to serve. At Milvus, we actually don't really try to solve all of the problems because, for example, if someone is working on problem space here, maybe Chroma or pgvector is easier to get started. Milvus is kind of sophisticated because it's distributed architecture. Even though we kind of developed a thing called Milvus Lite, and for this area we have Milvus standalone, which is everything compacted into one single Docker container. But really the flagship product of Milvus is the distributed version that's good for the actually have a visual for that. The other more challenging search serving problem, that's where Milvus is designed for. And also very fortunate that we have a very supporting community. Recently, I think Milvus has crossed 38 stars on GitHub. I think now is a good chance to celebrate that. But this can't be achievable without the users, without anyone using this, maybe fixing bugs or raising issues on GitHub, and also contributing code to Milvus. So really, really thank you for that if you are already using Milvus. So the latest version of Milvus is 2.6. With the spirit of solving the search serving problem at scale, we are designing a few. We have designed a few sectors to improve the quality of this product. One is lower the infrastructure cost, because once reaching the billion scale vector search, people actually start to worry about cost. Because say if 1 billion vector, that's probably 5 terabytes of data, and serving that from memory, that's really, really expensive. That probably means $500,000 to $1 million resource cost on AWS. And we're also trying to boost the developer productivity by enriching the feature side of Milvus, such as supporting new data type. We added support for geo data type, for example. We're also streamlining the embedding and vector search workflow so that the 2.6 version of Milvus can support integrating embedding model into the on the server side, so that you can just send text and then it will trigger the embedding and generate the vector and then ingest the vector, always the one single API call. We are also trying to deliver the performance consistently, even at scale, and this can be done without new architecture. I will also introduce that a little bit in a little bit. So the first thing I want to talk about is quantization. Again, in the problem space, if there's high KPIs and the scale is large, actually it incurs a difficult challenge to serve that efficiently. So quantization is actually a way to reduce the precision, by sacrificing the precision, reduce the resource footprint of the vectors, rather than storing the vector as 4-bit or 32-bit full precision float point. You can, maybe half it into FP16 or use 8-bit as an integer. You can also do 4-bit, 2-bit. But the most interesting quantization we have seen is actually a single-bit quantization. It sounds counterintuitive because, reducing the data from 32 bits all the way to 1 bit, that sounds too aggressive. And it is the case before RaBitQ. So for the naive binary quantization, it actually sacrifices a lot of the quality so that renders this not usable in production. But RaBitQ is really a smart way leveraging the mathematical characteristic of high dimensional space. So vector search, the dimensional is usually thousands of dimensions or even higher. So an interesting geometrical property of this is if you plot the distribution of the value on each single dimension of the vectors, for 3-dimensional or low dimension, it's actually uniformly distributed. This is expected, but counterintuitively in high dimensional space, it heavily concentrates to 0, which means there's a lot of opportunity to compress because it's not really using those space in the value. So RaBitQ, it uses a smart way, it kind of models the vector as one of the few points in a cube. So in 3 dimension, it looks like this. So think of there's 3 dimensions. For each dimension, there's one single bit that represents 8 things or 8 values. Those 8 values define this cube. So instead of using coordinates to encode a point on this sphere, it actually just approximate that into the closest point on this cube. So that this way it achieves saving the storage cost from 32-bit to 1 single bit. But the reason that it doesn't hurt quality that much is because, again, in high dimensional space, the distribution is heavily skewed, so that by doing this, it actually doesn't really hurt the quality that much. This is, I think it's very interesting and special finding, applying the mathematical characteristic to a real world application. Of course, there's some nuance, like for example, it actually rotates the cube to optimize for this approach. But we implemented RaBitQ in Milvus for this 1 single bit quantization and did the benchmark. The result is very, very impressive. So we can compare to the baseline. The baseline is the very top. So it got 32 bits in terms of the memory footprint. So if we just simply use RaBitQ as it with no refinement, refinement is an optimization on top of RaBitQ that we'll talk about a little bit. So it actually saves 32 times, but it also can achieve higher QPS because now each vector is smaller. So the computation on the vector is actually more efficient. So it doesn't only achieve cost saving on the memory, but also achieve more QPS. Of course, the recall is sacrificed, but still is decent recall, 76%. For some of the applications, it's just usable out of box. But for some applications, you actually require more than, say, 90% of recall. If that's the case, we can still add refine on top of RaBitQ. So basically, RaBitQ is being used as the first stage retrieval, and then internally, there's another refine stage. So you overfetch with the RaBitQ because the quality is lower. You overfetch, you kind of compensate for that quality loss, and then refine with the, for example, SQ8 version, a higher precision representation than RaBitQ, using this for refinement, and then you pick the best from the first stage retrieval. And this can achieve 95% recall and still slightly smaller QPS, but still very good performance compared to the top, the baseline. It's about 3 times QPS gain. So this thing is available in Milvus. The new index type is called IVF RaBitQ. The other interesting thing I would like to introduce is tier storage. So before we talk about this problem space, so if that's high QPS and say large scale, I would say quantization is the best mechanism for optimization. But for large scale, small QPS use case, we can actually optimize the latency of this because you don't really need to serve as much search QPS. You can make each query more expensive, but saving the cost on storing them. Instead of storing them in very expensive RAM, we can store them in RAM, SSD, and also object storage. So in this case, tier storage architecture so that it automatically dispatch the data between these 3 tiers. All of the data lives in object storage, super, super cheap, but of course, very slow to access compared to RAM and SSD. And then RAM and SSD are being used as cache, essentially. So you leave the hot part in the cache, but all of the code part is still living in object storage. This can achieve probably 100 times cost saving compared to serving everything from RAM. And it has the complex LRU scheduling mechanism. So basically kind of swapping things and juggling based on the access pattern. The latency, of course, won't be as good if serving from RAM because there could be cache miss. And if that's cache miss, it needs to go to object storage to retrieve the whole segment of data and then bump it up to RAM and then serve the search from the RAM. But it will be a good solution for the case where you have massive amount of data, really low access frequency, say 1 QPS or less than 1 QPS, and the latency target is not as strict. So the latency implication of this is usually 100 milliseconds to a few seconds, probably 1 second or a little bit more. Depends on whether it hits the cache or it actually involves retrieving from the code part. In addition to the new features, the architecture is also changed from 2.5 to 2.6. So this is the architecture of 2.5. So you might be familiar with this. There's query node, data node, index node, each responsible for different things. But we have seen a lot of times if there's a huge amount of ingestion, streaming ingestion from the message storage, it actually becomes the bottleneck. So the decision that we made in this architecture change is that we remove the message storage, message queue, rather than using Kafka or Parser. It's still available, but we provided an alternative called Woodpecker. And for data node, because now there's no message queue and the responsibility of data node, which is subscribing to the fresh tier of data, can be, we kind of rethink about that and divided the responsibility into 2 things. So the change is that, so the streaming of things is handled by streaming nodes with cooperation from RaBitQ head log. The RaBitQ head log can be implemented with Pulsar or Kafka or Woodpecker. And Woodpecker is more efficient if you have a large amount of ingestion in real time. And the streaming node is also taking the responsibility of serving the fresh tier. So historically, the query node was responsible for serving both the historical tier, like the data you have ingested a while ago, and the data that you have just ingested, which is the fresh state. And because it separates this, so the query node has a more dedicated purpose. It helps serving the existing part faster. And for the streaming node, got 2 benefits. One is that it's powered by RaBitQ log implemented in Woodpecker, which is lighter. And the other thing is it can scale in addition to scale kind of independently from query nodes. So let's say you have a lot of fresh tier data. you can actually stream, or you just expect the streaming throughput is higher. You can stream you can scale up the streaming nodes independently. And the data node is pretty much taking the responsibility of the old index node, responsible for retrieving the new segment from the object storage, indexing that, and then place it back. And then there's scheduling of loading the newly indexed segment into the query node, and because that becomes the hierarchical layer. And so this enables Milvus to support even larger scale data streaming. Let's say you have a use case of constantly updating your corpus, ingesting, I don't know, millions of documents in an hour or something. This will actually be very helpful in improve the performance of that. And functionality-wise, we also added the streamline of embedding model. So traditionally, people think of vector database as a vector in, vector out facility, right? You need to prepare vectors outside. For most of the cases, that's fine, but for some of the developers, they just simply want to enjoy the convenience of having one single facility that streamlines everything. So we actually built the embedding function into Milvus. The embedding function supports the embedding service and also open source embedding model hosted by Llama Index, VLM, and a few other popular inference frameworks. And in addition to that, we also added the re-ranker function. So re-ranker function technically this is a model-based re-ranker, cross-encoder, so that if you use, say, BGE re-ranker or Quinn3 re-ranker, you can actually plug it into this as well. And now the APIs changed into, of course, you can choose to ingest vector or search by vector, but you can also ingest by text and search by text, even for the embedding-based retrieval. Before in 2.5, only full text search is supported in this fashion. Because in full text search, the BM25 scoring is actually done inside Milvus. Now you can let Milvus do the vector embedding for you as well. So with that, it's also easier to build a hybrid search, so that now you can have BM25 retrieval and embedding-based retrieval together in Milvus. Traditionally, you need to run the embedding model outside of Milvus. We also improved the full text search functionality as well. A few things: multi-language tokenizers. Some people want to fit in multiple language of documents in one single corpus. Now you can define the analyzer to support, for example, Arabic and Chinese and English. We also added phrase match. So phrase match is basically using the similar mechanism as full text search, but instead of just searching, it allows you to define more finer grain semantics, such as I want to find machine learning. I want to find the rows that has a column called, say, title that contains machine learning, or something similar to machine learning, say, probably not AI because the distance is too far, maybe say deep learning, or say deep neural, okay, deep learning. So using phrase match, you can do that on a column directly without involving a full text search. And we also added time-aware decay function. Let's say you want to further fine-tune your search experience by applying the implication of a Scala field. For example, is time, right? So for the older content, I will just penalize that. For fresher content, I will boost that. You can implement you can just simply implement the re-ranker by calling the time-aware decay function. And another re-ranker that we introduced is boost re-ranker. So the boost ranker can help you boost the content that miss a filtering predicate. For example, I want to boost the things that has price less than $100, or I want to boost the things that contains the word apple. And the mechanism of this is similar to the term boosting in Elasticsearch, if you are familiar with that. And those things are new functionalities we introduced in full-text search. And we're also adding support for structured list, which is to model the data in a structured, hierarchical way. So for example, you have a document, and a lot of people wants to chunk the documents into smaller pieces. And before, Milvus can only store this as a plain list of chunks. But you either replicate the labels from the document to chunks, or you might lose some information in terms of the hierarchy. In the structured list, we support kind of defining a super row, and in the super row, it contains multiple chunks. So you can store a single document in a single row rather than splitting it into multiple rows. And this achieves both efficiency in terms of not replicating all the labels among multiple rows, and also sometimes it's just easier to manage the complex data structure. So we also have the involvement we also supported the involvement of the schema, and I did a few more index types. So common, I would say, complaint about Milvus is, oh, if I forgot to define dynamic schema from the very beginning, there's no way for me to change the schema anymore. But I do want to add a new field. So we just added the add field support. So now you can add another field just in the existing schema, whether it's an individual field or it's a dynamic field. Sometimes the dynamic field and other JSON formats, people also want to define flexible index on that. So in the past, you can only define index on each individual field by specifying the JSON path. But now we just made it simpler. Now you can define the index on the whole JSON. So no matter what kind of field it has, all of them are being built with index. And also introduce new index type ngram, which is good for, which is more efficient for varchar field. And a new specialized index type called min-hash LSH for data deduplication. So if you want to find the near duplicates for a large corpus, say people working on web search or data, large language model data training data curation, they want to remove all of the duplicates. Maybe the duplicate is just two documents that vary by a single word. For those cases, they can use min-hash. It works better than using the exact hash because that's too strict. And lastly, embedding list, which is the structured list that I just mentioned, that's also that's coming soon. And this is the I'll skip this for that. But in addition to this, for the future of Milvus, we're developing a very exciting new thing. So if we reflect on the journey of Milvus in the past few years, in 2.0, we added filter search. So vector search can be used together with metadata filtering. In 2.5, we added full-text search. Now you can use full-text search together with embedding-based search for hybrid search. In 2.6, we added tier storage to make it cost-efficient at billion scale. And for 3.0, what do we do? The answer is actually we're building a vector lake. So once the data scales beyond the billion, it's actually such a challenge to control the cost, because serving a billion is already expensive. Serving 100 billion is probably, the cost is not bearable. But on the other hand, we also see more and more ask for a unified data platform to streamline everything from data management to data serving, so that we're building this multi-model lake that basically treats vector as part of the data lake. So you could have a data lake, and in addition to that, there's all of the data can be vectorized, so that traditionally in data lake, we got people working on data lake. You can only run, say, simple queries or dealing with numeric data. but it's not very easy to extract the insight from the unstructured data, such as raw text or say images, so that we are building this new platform. It combines the vector search functionality with the property of traditional data lake, which is to manage massive amount of data and deal with the schema evolution or the data evolution. And this can be used for use cases such as cleaning the data for the training corpus, or just extract labels, and also mining the data for business insight. So that's all I prepared for this talk. I hope that you will enjoy 2.6 and give it a try. So on the left is the GitHub repo of Milvus. On the right are a bunch of learning material for building RAG, agent, and other AI applications. Thank you.
Awesome. Before you leave, do we have any questions for Jiang? Oh, go ahead.
Yeah, it's possible. So the question is that possible to customize the model or introduce any model that maybe that's not publicly available? So as long as the model can be served by the frameworks that we support, for example, BLM, Llama, and also Hugging Face TI, those platforms, I think you just need to convert the format of the model into a common format like Onyx or something, and then it can be served in those platforms. So Milvus doesn't integrate with the models themselves. It integrates the inference platforms, open source inference. Yes. The question is there any compatibility issue migrating from 2.5 to 2.6? So first of all, for 2.6, it actually supports both Woodpecker and message queue like Pulsar and Kafka. I think recently we have heard some people migrating from 2.5 to 2.6, and I think it's just safer keeping all of the topology. For example, if you were using Pulsar or Kafka, just keep that and then migrate to 2.6, and that will just save the hassle of dealing with that. And after that, I think we still need to introduce a more well-lit path for migrating from Kafka Pulsar to Woodpecker, and that's something that we're working on. Oh, backward compatibility? Not really. You can upgrade to the latest version of 2.5, and then upgrade to the first version of 2.6, and then upgrade from the first version of 2.6 to latest version of 2.6. What kind of security feature, for example? So that's a few things. So first of all, we have RaBitQ, like I'll say a common access control mechanism in open source Milvus already. And on fully managed version of it, we are adding more security measures. Because it's a fully managed service, it's easier for us to apply more control mechanisms such as CMEK, bring your own key, so that the key to encrypt the object storage, which is kind of the persistent storage layer of Milvus, that's the key is being rotated and it's managed automatically. For open source Milvus, self-hosting that requires some careful management on the infrastructure side to make sure that the key is being managed securely. Yeah, I'm not sure if that answers your question. Yes. Uh-huh. Yeah. Mhm. I see. So the question is about the embedding list. The common use case of embedding list is one, chunking documents. The other one is image and video, because the video contains multiple key frames, and the key frames can be organized as a subset of the video. So those are the use cases that were designed for. And in those use cases, a common pattern is that I just want to search on the I would say lowest level of content, which is chunk or video frame. But I also want to keep the metadata information about this video or document with the chunk and the video frame themselves. So the video itself is not being embedded per se. As the video is represented by its keyframes, just like the entire document is not embedded either. So the retrieval technically happens on the subset, on the chunk level. Yeah. Okay.
Good?
Yeah.
Okay, awesome. Can we give another round of applause to Jiang, please? Awesome. Right there. All right, now we're going to pivot and head on over to Cole and Aria from the data infrastructure team at Airtable. And we got. Thank you. Yeah. That flips. Okay.
Yeah. So hi. Spacing sound okay? Okay. So I'm Aria. We both work at Airtable, and we're talking about our journey building semantic search with Milvus. So maybe we should start from the beginning. What is Airtable, and what do we do? So our tagline is we're one source of truth for all your critical business data. So what does this actually mean? So I like to think of Airtable as you start with a spreadsheet. You have your rows, your columns, your data is in there. And then you want to build on top of that. And that's where Airtable's real power is. So you have multiple tables. You can click into a row and it'll map to a different table. You're building your relational model. And then the next layer is automation. So I want to sync with any external source. I want to import, export, automate this sync to happen every day. That's where you can use Airtable's automations. And you can trigger the workflow to change your data in any way you want and keep it up to date. And then the next layer is interfaces. So if you want to take your data and build a nice interface that people can interact with, view in a certain way, share with certain people, you can build that and like use it for anything. Like a good example is product management tools. You can build a nice interface to see where the whole sprint's going. And then the last big use is Omni. So this is something we released this year for AI chat. So you can ask it questions about your data. So if you have a really big table, you have a lot of insights you want to unlock, you can ask it questions along with generate and build any table you want. So how do we personally use Milvus? So I'm going to dive into two big examples here and just kind of ground it in the product as we get into our process for how we productionized it. So the first one is AI chat. So here, I'm going to go through a little example and then I'll get broader. So in this example, I made a little table with like 100 rows of feedback about an iPhone. And if I want to ask AI chat questions, I wanted to be aware of my data and actually answer those questions. So I asked a question of like, what percentage of the feedback is about battery life? It could tag like, we have 20 comments about it, this many are positive, this many are negative. But you can go a layer deeper and say, hey, I don't want it to include the word battery. I wanted to truly understand which ones are about battery life. And you pick up ones about charging, and it's using semantic search. So we use a combination of Milvus and our AI models to give you the best answers we can. The second big one for us is linked records. So like I said, Airtable is a relational database model. So here in this example, I built 2 tables. One is a list of random names of people and a sport they play, and another one is a table about a large list of sports. And if I want to give them an alternative sport, I let Milvus go and look at what row, look at that row, look what sport they're playing and find something semantically similar and suggest it. So if someone's into tennis, we recommended golf. If someone's into swimming, we recommended diving. And so those recommendations are based on semantic search from Milvus. And so this is our first, this one's out. And then one of the things we're really thinking about is trying to use agentic search to improve our Milvus queries and get more accurate search results and recommendations over time. So how did we decide on Milvus? So I walked you through 2 examples. These are constantly users querying this data. And so one of the most important things to us was really fast query performance. We want a very snappy experience. The other one is we want to scale to really large bases. Your AI chat search for insights is really useful when you have like a database with 500,000 rows. You can't feasibly read through all that, and you can leverage Omni to get better results. So we wanted Milvus to support that, along with the support to millions of bases. We want to support a lot of users, and Airtable's pretty big. So we launched in just April, and we have 650,000 bases currently in Milvus. And this number seems to keep growing. Users are excited, and so we want to keep supporting them. And the last thing for us is we really wanted to self-host. We wanted that level of control over our systems. And so this is part of our journey for self-hosting.
So I'm Cole, introduce myself as well. I'll talk a bit about how we went down the process of productionizing Milvus and sort of the challenges and stuff we faced there.
Bottom.
So first I'll start with the ingestion flow. On the right side, we don't care, as we made the decision to basically optimize for query performance. So on the right side, we use a queuing mechanism to basically allow us to rate limit and control the flow of ingestion, and we make the sacrifice of consistency. But ultimately, when a user first opens AI chat, we make the decision to basically embed all of their data. And at that point, we enqueue some tasks which fetch the data, send it to the AI model for embedding, and then write that data to Milvus, ultimately. And then subsequently, every time the base data changes, we enqueue subsequent events to basically re-embed those changed rows and upsert to Milvus. On the query side, like I said earlier, we want to optimize for the lowest latency possible. So we serve those directly. We just have a thin service layer that ultimately will, when a user opens the AI agent, or sorry, the AI assistant, they will, if we deem that their search is relevant to their base data, we'll send the request, we'll basically embed that request, send it to Milvus, query for the nearest neighbor, return the results of those vectors after permission evaluation back to the user. We set up a lot of like monitoring and observability around Milvus to make sure our clusters are in good health. We have a bunch of exposed metrics that we've taken advantage of there. We have the Datadog agent that exports those metrics, and we basically monitor them and have alerts set up in correspondence with those. In particular, we have like client-side metrics which evaluate like basically all the way up to the customer how those routes are being served and any error rates there. As you can see, there's our dashboard. On the system side, we monitor basically our cluster health. We deploy internally in EKS, so we have a lot of basically pod level metrics that we monitor and ensure. We basically use those metrics to ensure the pods are in good health. In particular, like obviously like CPU, memory utilization, and restarts, stuff of that nature. Yeah, lastly, like we have internal Milvus specific metrics that we've learned to keep an eye on. In particular, we're on Milvus 2.5, so I know the architecture changed quite a bit in 2.6, but for us, we keep an eye on compaction and indexing. We've noticed that those can have an effect if they are starting to fall behind. Internally, we run load tests, and we've established limits that we know to be valid, and we use those to basically evaluate our runtime health. In production, we often have to node rotate to support operating system updates, security patches, things of that nature. And in order to do that effectively, we have pod disruption budgets and mechanisms that we've put in place to ensure a graceful handoff of state and in order to not induce downtime. In particular, for our query nodes, we serve data out of memory. So we have to have a handoff when we're rotating all of those. And so, yeah, like I said, with pod disruption budgets and readiness checks, we were able to do that.
Yeah, that's correct. Yeah, so some of the other things to productionize this. So one of them was our roll out and upgrade process. So like over the course when we started using Milvus, I think we were at 2.5.1 or 2. It was very early and we've had to keep progressing. We always want to stay up to date. There are a ton of new exciting changes and our scalability limits keep improving. And so as we constantly do this, along with as our product team comes to us and says, hey, we have a new feature, we want to support a base that's even bigger, we want to make sure we can always provide that. So the way we approach it is we have a standard process of running a load test, hammering it with as many queries and ingestion as possible for a few days, and like comparing the performance against our previous benchmarks and growing confidence from there, along with things like rotating nodes, trying to destruct the possible in any way we can to really feel confident that if anything happens in production, we can recover. And so once we have that confidence for any change, it's the normal CI/CD pipeline. You roll out through stages and bake it for a while. The next big piece for us was data recovery. So we were really excited about this and we wanted to get this to production as fast as possible. And so the way we approached it was, hey, we're starting with smaller data. Let's use that to our point. Vector embeddings are derived data, and we always have our real data persisted. So in a disaster recovery plan, it takes us minutes to spin up a new cluster, and we can say on demand, you can go embed it. And so our customers shouldn't see a lot in like a true worst case scenario. And by this, I mean like our S3 files got corrupted. This is really hard to cause, but we wanted that safety before we put this out in production. So yeah, and then the other key part about this was we didn't want users to have a bad experience when this happens. So your search results may be a little less quality, but it's not like it's going to error out. You're going to have a smooth experience, and we're going to get this up as fast as possible. And then we essentially go back to from the time a user last queried, we prioritize those for re-embedding, and over the course of time, just re-embed all the data that was in Milvus. So this was a great first pass for data recovery, but one of the things we're really excited about is Milvus supports snapshotting, so you can recover from a point in time. And as we keep scaling, that's something that we want to be on. And the last one is offloading cold bases. So this is kind of similar to the last talk of like understanding user patterns. Not all your data is queried very frequently. And so we started to really understand our data patterns. We noticed that not everything's being queried. Embedding data is pretty cheap, but storing data in memory is less cheap, and our query node costs can grow pretty quickly. So because we're on 2.5, we formed a manual process of going and releasing nodes, which means that it will pull from S3 on load time if needed. And we were able to get a lot of our data just to be in S3 and our query nodes to run a little leaner. This gave us a ton of scalability on 2.5. And whenever we're on 2.6, this happens out of the box. Okay, those are some of the highlights from our process, but let us know if you've got any questions. Like for data recovery, we don't do it just yet. So we're not small enough that we can just re-embed on demand. We thought about doing it every few days and expiring old snapshots, but not scoped yet. Yeah, so we have 650,000 partitions. I think on the order of 10 terabytes of data, something like that. Yeah. Yeah, so for us, every base, so like every spreadsheet essentially you saw, for lack of a better word, is a partition, and it gives us a lot of isolation. This also supports our way of doing cold offloading because you can just release the whole partition. We scale each cluster to about 400,000 partitions in our current world. And I bet as we keep upgrading, it can go up.
In order to support all that data, we also have on the order of 16 query nodes with around 50 gigabytes of memory, something like that. And we keep them at like 60 to 70% memory utilization. That's helpful.
This one? Yeah, so it's
Yeah, so basically, as I mentioned, we hold all our data in memory on the query nodes, and we only keep one replica, and that's for cost purposes. So when we undergo periods of planned maintenance, we basically have to do like a graceful handoff of that state. And Milvus handled this out of the box. When you send like a sig term to a query node, it'll basically offload each segment one by one, and the coordinator will reassign those segments to other query nodes. But we do this one at a time to basically ensure that we don't because we run our query nodes pretty hot. We keep them at like 65 to 70% memory utilization. So if we're not careful and they're all start releasing at the same time, we've encountered issues where our cluster goes down because they Say what? So basically during the rotation, we send a sig term and we basically spawn a new node. And as soon as a new query node comes up, we wait around 10 minutes. We set our readiness probes to just delay, basically to give it time to fully rehydrate. It's probably excessive. I think it would probably be okay to just let it to just basically rotate one at a time. And as soon as a new one comes up, you can trust the coordinator to basically reassign as it may. But we wanted to basically have the least amount of churn. So like basically send a sig term, allow all of that data to be reassigned to the fresh query node before we start rotating the other ones. If that makes sense. Yeah, so we do technically we actually do permission on both sides of it. We do some row level permission checks before, and then we filter out for the rows for which that user has permissions. But the column level permission checks we're not really able to pass down to the query. So those we end up doing after the fact. And yeah, we basically, like you said, we basically fetch enough results so that after we do permission checks, we expect that number to still be enough to return to the client. Yeah, it's complex to be quite honest. I think we do have something to that. I don't really know exactly, but something to that effect. Yeah. Like soft.
For like version up, like for Milvus upgrades. I think we've done them about every month.
Like Milvus versions or?
I think, huh? 1 to 2 months, I think.
Every 1 to 2 months. We spend some time with each upgrade doing regression testing, load testing, stuff of that nature. So we try to basically amortize that over, a few months of releases. And we haven't upgraded to 2.6 yet. Yeah, the query nodes for sure are definitely more memory bound.
Yeah. Yeah, we're really excited about that. I think that was also one of the reasons we invested in cold offloading before 2.6 was out. It just gave us a little more bandwidth. Yeah, definitely. Yeah, definitely. I'm excited for it. In the hundreds. Yeah. Yeah, so we do it as everyone changes. Like any rows get updated, we capture those updates and do them live, and we run them through our queuing system.
Yeah, every CRUD request, we basically compute a diff, and any row that's changed, we send to be re-embedded and upserted back to Milvus.
Awesome. Thank you.
All right, thank you, Aria and Cole. Oh, thank you. All right, we're going to head on to our last speaker talk of today. We have Nick from SAP, data scientist, and
Hello? Okay. Let me just make sure I know how the clicker works. Okay, sweet. Okay. Hey everyone, my name is Nicholas. I'm a data scientist at SAP, and I will be giving a presentation a little bit lighter, a little less technical about designing agentic systems. Just a little bit about my background. I mentioned I'm a data scientist, specifically for Concur, which is an expense report management software. I studied data science and math at UCSB in Southern California. I like to go on hikes, and I'm also on my 10th month here at SAP. So just for starters, to just broadly cover agentic systems, I'm sure if you've been driving into San Francisco, you've seen all the billboards. Agents are sort of the big thing right now. Makes me think of the Flex Seal commercial, some guy just trying to slap an agent on everything. But as they're this big thing, there's a lot of differing definitions about what exactly an agent is. Some people take the approach where agents are more non-deterministic. They have their own agency to do what they want. Some people define them in a more deterministic way with a more well-defined prescriptive implementation. Both of these fall, in my opinion, and also via a blog by Anthropic, into the category of agentic systems. And also, LangChain, a popular framework for building agents, discusses that oftentimes in production, agentic systems are a compromise between both of these things. Oops. So when are agents good to use? In my experience, I've noticed specifically in scenarios with complex reasoning, maybe there's some dynamic decision making, and especially in cases with unstructured data, which we've also heard a lot about up until this point today. And so what exactly makes up an agent? Ultimately, agents themselves, or the main system of an agent, is very, very simple. We just have the large language model acting as that brain. We have tools that allow the agent to interact with its environment. And then finally, we also have some form of memory, be it shorter or longer term memory. Short-term memory oftentimes resembling that context that the large language model has access to, or longer term memory maybe an understanding of previous interactions with a user or a system, maybe some sort of preferences in that regard. So when it comes to actually building these agents, we have this really relatively simple structure of the language model, the tools, the memory, but there are a ton of different frameworks that have come out since agents have gained popularity, specifically LangChain, LangGraph, Crew AI, OpenAI agents, SDK, the Google ADK. I think there's small agents, there's atomic agents. There's a lot of frameworks, but like I mentioned, these things ultimately are relatively simple. They implement the same loop. Here we have an image of a LangGraph agent. I also would just like to add that a lot of the challenge when it comes to building agents is not actually the agent itself, but the entire system around it, sort of like with maybe a Milvus database, as we saw with the Airtable folks talking about all of their systems for deploying to production. So what is that loop in essence? It's starting by feeding messages to the large language model, system prompt, context, maybe some facts about the user that's interacting with the system. Then we say, okay, well, did the LLM call tools? If it did, call those tools and add the results back to the messages. And if it responds with text, maybe in a user-facing scenario, try and get some feedback. Or maybe if it's more in a non-conversational solution, do something custom. Another example on maybe when this loop would conclude in a non-conversational context is providing a tool to the agent called maybe something like provide final answer and catching that call and ending the execution at that point. So like I mentioned, building the agent itself is relatively simple, but building the system around it is oftentimes very difficult in a couple main components. First of all, security can be pretty challenging. There's also the issue of malformed or incorrect tool calling made by an agent. And then finally, the issue of message history and context management, which under a lot of, in my opinion, more efficient use cases or high quality use cases becomes very, very important to get right. So starting off with the hidden challenge of security, here we can see agents sometimes are being malicious. They can generate pretty bad outputs. So I don't know if you guys saw a couple months ago, there was an example where a Replit coding assistant deleted a production database. Or there's the Gemini coding assistant deciding that it should turn itself off and that it has no purpose because it failed to do something properly. And so oftentimes we can see that large language models can go off into the deep end doing something that ultimately doesn't serve what we want it to do. Another problem of this could be in user and company data isolation. So let's say you're working on an agent that has to be compliant with the data. Well, let's say that the agent has control over the user ID it's putting into a tool. Then maybe it can randomly generate a different user's ID and pollute the data that it shouldn't have access to. So in my experience, what is some solutions to these problems? First of all, just designing interactions with a set of implicit guardrails, not even giving it the ability to mess up. So in that case, with the Replit coding agent, you can probably check to see, is it trying to remove a production database or is it a command it wants to execute similar? Don't even let that happen. Or in the case of company and user data isolation, don't even give it the opportunity to fill out or generate a user ID. Make an instance-based tool, potentially, that has the user ID properly defined ahead of time, before the LLM can interact with it. Another thing, too, is the hidden challenge of malformed function calling. So LLMs can generate tool calls with incorrect arguments, get an error back, and rectify their decisions. But there's also an issue of failing to even generate something that's recognizable as a tool call in the first place. So in a lot of these open source frameworks, LangChain, for example, when a language model makes a tool call, this gets pulled out and put into the abstraction that you interact with as an engineer or developer. But sometimes it does something wrong and you just get some text. Like oftentimes I noticed Gemini will like to try to print out something. Like it'll say print default API dot the function that you provided. And so this can really, really break up the flow that you've designed for your agent. Maybe it's doing something important, it generates a malformed function call, and if you weren't prepared for that, then the session can break, something can go wrong. And so the solution that I found works best for these instances is making sure that tool definitions are defined in a very simple and understandable way, considering maybe not like a human computer interface, but more an agent computer interface. Defining tools with primitives, so using very, very basic types, avoiding multi-nested JSON schemas and the like. And then also, in another event, you can also implement some custom error handling. So let's say that you can catch that Gemini is trying to output a print statement. You can take that message, filter it back to the LLM and say, hey, did you try and do this instead? And then lastly, the hidden challenge of context. So language models and agents can forget things a lot. And as models have improved in efficacy, we've seen discussions about larger context windows. So if I'm remembering correctly, I think Gemini might have a context window of 2 million tokens. But despite this, given research, we can still see that even when we approach these larger contexts, agents are still, or large language models are still forgetting things, even if it exists in this larger context window. Context is incredibly important. Oftentimes it helps agents understand their task or get new information via a vector database or in sort of reference to that shorter or long-term memory I talked about earlier. And so when it comes to agents forgetting things in a long context window, research has shown that oftentimes keeping things at the top of the context that are most important, that will help these things remember. And then also designing RAG systems to pull in context dynamically, maybe summarize context or different mitigation strategies can really help avoid this issue or avoid this challenge. So my library of choice is LangChain and LangGraph. Here's a little joke with my team. I always talk about graphs in stand-up. We like to make stuff and send it to each other. This is from the SpongeBob movie, if you're unfamiliar. Well, why do I like LangChain and LangGraph? For a couple main reasons. One, it offers a pretty great set of both high-level and low-level APIs. So when you're having to address these challenges with agents, having access to low-level APIs where you can develop custom solutions that are compliant within your use case and efficient and maybe mitigating different things, it's a lot easier to do with LangGraph than it is to do with some of these other open source frameworks like the OpenAI SDK or the Google ADK. This does present a little bit of a challenge because the learning curve for LangGraph can be a little bit higher than some of the other frameworks. So maybe for quicker prototyping, I think the other frameworks are a little easier to use. But because there are some high-level APIs that LangGraph also offers via LangChain, some of these things do get slightly easier, just with less control over those mitigations. It's also called LangGraph because it represents an agentic system as a graph. So getting started with LangGraph, if you guys are interested, I'd highly recommend looking at two separate functions, create agent or middleware, which is a part of their 1.0 release that they just did, which allows you to add hooks onto different things that happen before and after a call to a large language model. Or you can just get into the weeds and start with LangGraph, which is what I did around a year ago when all of this stuff was starting out. This is me being super excited. What am I excited about? I would say fine-tuned small language models. So right now in the large language model space, we have a couple big players, OpenAI, Google, Anthropic, X. And they create these incredibly large language models that store a lot of information about different things in their weights. But oftentimes, agents are focused on small individual tasks. And if I have an agent that's meant to, let's say, extract information from a document, it shouldn't really have to know about Nietzsche or another philosopher. And so with a fine-tuned small language model, oftentimes you can improve the performance of the agent or of the predictive task at a fraction of the cost, both monetarily and then also in terms of inference time. If you are interested in small language models, check out Hugging Face. And that's it. Any questions? Also, if you want to connect with me on LinkedIn, I didn't know about the QR code. I'm like very new to the whole thing of having a job in tech. So yeah. So when it comes to incorporating guardrails with agents, this is where I think LangGraph really shines in that you can split up and define a more deterministic flow around a specific task that handles guardrails specifically. And so, for example, if we're talking about the guardrail with user and company ID, that becomes more of an engineering problem about how do we instantiate tools where these things are baked in and the agent doesn't have to worry about that anymore. Or, yeah. Does that answer your question? Any other questions? Oh, sorry. So when it comes to a publicly available repository of tools, are you familiar with MCP? So I would say that MCP is probably where I would look first. For those who are not aware, MCP stands for Model Context Protocol. A lot of different companies will expose MCP servers. And so an agent can access the server, get information back about what tools are available, and then call those tools. So for example, I think Atlassian has a Jira MCP. I do not know the answer to that question because I'm more on the Concur side of things. The business technology platform like the SAP solution. I'm not super sure. So when you say guidance, do you mean more on an implementation side or like? So LangChain and LangGraph actually exposes a couple abstractions to really easily build in human in the loop to LangChain and LangGraph agents. I think my own personal opinion when it comes to human in the loop scenarios would be to maybe, I guess it depends on the context, but I think I have a preference for a human in the loop scenario where an agent can ask more a yes or a no question and avoid sort of a free text response. Just because with free text, you enter some challenges regarding compliance and security, whereas with a yes or a no question, you can maybe have an easier time solving those problems. Any other questions? Okay, thank you.
Okay, we're going to be moving on to the next segment of our meetup. Okay, moving on to our raffle giveaway. Before we start, does anyone have any last minute entries? You just raise your hand and then we have a team member come get you. No? We good? Okay. Oh, I think you get them. Get them added. Yeah, you just need to star us on GitHub or alternative, just add us on our LinkedIn, I have Milvus or Zilliz, whatever you guys prefer. You can just throw in the raffle now. Thank you. Okay, all good. Any last people? Okay, we're actually gonna have one of our speakers pull the first giveaway. We have two we're giving away today. You wanna do it? Okay. You want to call the
550010. Wait, it's not me.
Okay, again, 550010. Is that you? Awesome. Okay, let me go ahead and get you the bag. You can grab the next one. You want to call the next
Pick one? Okay. Make sure I am not seeing it. So it's 550013. Who's the lucky guy? All right. Thank you so much.
Oh yeah, sorry, last thing before we end that guided session, the meetup. If you like what you heard today and something resonated, we do have office hours. You can hop on a one-on-one session, it's about 20 minutes, and just talk a little bit more about how you wanna, power your next AI product. But yeah, that's pretty much all from us. Feel free to continue networking, grab some food, some drinks. And yeah, thank you guys again for coming.